Unit 14 will be our last unit before we get to your final. And Unit 14 will deal with something that some of you don't really like to deal with, which are fractions. The whole unit is on these things called rational expressions, or things that have fractions with variables in them. And so the very first concept we are going to cover with rational expressions are how to find the domain of rational expressions. This makes a big difference when you go to Honors Math 3 and into Advanced Math for those of you who will struggle with Honors Math 3. Okay? The domain of a rational function lists all possible inputs that make a real number. Sometimes you won't get a real number. That's something we learned this last unit. Or a couple of units ago when you were square rooting negatives and you had to deal with I. I was not a real number because you were square rooting negatives. That's one possibility. There's not going to be a lot of that in this unit, but there will be a lot of division by zero. If you divide by zero, it does not exist. Division by zero creates something in mathematics that creates a infinite solution or a negatively infinite solution. So because those two things aren't the same, the mathematician said that this doesn't exist. It's undefined. When in reality, it's mostly because it goes towards infinity or towards negative infinity is what the real reason is, if you've ever wanted to know. So we are going to have to say, hey, the domain for these are all real numbers except for these values that cause a division by zero. You'll see what I mean in just a little bit. We're primarily going to be dealing with the top one. I only list this one just in case you're trying to connect it with what we've already learned, but there won't be a lot of this. The way we write the domain of x, there's a symbol. If you ever write this symbol, this is how I write it. This is how most math teachers will write it. And I couldn't find a font for that particular thing, so I gave you that one in when I typed it. But when I handwrite it, it looks like this. It's an R, capital R, with an extra line through it. This is the symbol for all real numbers. If you ever write this, you're telling me, or you're telling your math teacher it's all real numbers. This is to be read as this. The domain for x is listed as all real numbers except for x cannot equal, it can't equal, like it could be 1, x cannot equal 2, or x cannot equal -3, etc., etc. That's how we're going to write our answers when we find the domain. If we are asked to find the domain, it's going to be all real numbers except when the denominator is equal to 0. So a lot of times you're going to have to factor, and this is where the 1.2 through 1.7 notes are going to come in handy. If you don't remember how to factor, or you're a little rusty, here is the reference to the previous notes that you might need to look through in order to be able to factor as you're doing your problems. We're going to factor, and we're going to find the places where x cannot equal 0, and you'll see how I use this as we do some examples in just a little bit. The other two things that we're going to need to know how to do is we're going to have to know how when things are true. Equations are true when the left side is equal to the right side as long as you do not divide by 0. So you're going to be asked questions. Let me show you an example, like number 14, where it's going to say, when is this true? When is this equation equal to that equation? Is it true for all values? Is it true for all values of x except 7 and -7, for all values of x except -7, or never true? They are true when the left side equals the right side as long as you do not divide by 0. So if there's a possibility of dividing by 0, that's when something would not be true. I'll show you how we're going to do that on number 14. For numbers 10 through 15, you may need to factor and consider what domain is limited, what the domain is limited to when picking your answers. Should there be two O's in there? Limited to? No, it's not plural. No, okay. Okay, I'm just still Monday. I got a case of the Mondays. Okay. What the domain is limited to. Okay. Okay. That's my English. My kryptonite. There you go. Simplifying rational expressions. We are going to turn numerators and denominators into groups of multiplication by factoring, and we'll reduce anything that is in a group of multiplication. This is important. I can't tell you how many students don't realize how to do this correctly, so I'm going to show you something. A plus C over AB. You cannot reduce the A and the A. It does not reduce because this A is not a group of multiplication. This A is adding to the C. So I cannot reduce these because it's not a group of multiplication. Down here, A is multiplying B. We could reduce this one, but we cannot reduce that one. What you can do on something that looks like this is you can do A over AB plus C over AB. You can split it. And something like this, then you could reduce over here and do something like that if you wanted to. These are equivalent, but you cannot just cancel out the A and the B if there's an addition symbol or a subtraction symbol. So I'm just putting that out there because I don't want you to make those simple mistakes. Let's do some examples about what kind of work you're going to have to do in your homework. This is number 7. If you want to take a separate sheet of paper out to do your homework on, that's totally fine. Number 7 says, find the domain of each rational function. This is a rational function. What does the word domain mean? What can you plug in for x? What could we plug into this function that will make it a real number? That's what it's asking us. And earlier, I told you the domain, basically any real number you want to, you can plug into it. I can plug in 7 squared minus 4 over 7 squared minus 9, and that will give me a real number. I can plug in 100. I can plug in 17. I can plug in -5. There's only very, very few numbers that you can't use. How do we figure out what that is? You probably want to factor both the numerator and the denominator just to check this out. The top factors, if you remember what the top factors to, tell the person you're sitting next to, and if you know what the bottom factors to, tell the person what that factors to. See if you remember. I hope you said x plus 2, x minus 2, or vice versa. Order doesn't matter. X plus 3, x minus 3. And so this factors to that, and this factors to that. And what we really are trying to figure out when we're looking for domain, it's all real numbers except where the denominator equals 0. The numerator technically doesn't matter in this case. The numerator would matter if it matched up with the denominator, but these don't match up. So here's what we're going to do. I can have all reals except where the denominator equals 0. I can have all real numbers except where x plus 3 equals 0. It cannot equal 0. The x minus 3 cannot equal 0 either. So a lot of times what you'll see me do when I'm working out my problems is I'll put this cannot equal to 0. If it does, then we would take this and we would be dividing by 0. Well, what would that mean? Subtract 3, subtract 3. That means x cannot equal negative 3. Or x, add 3, cannot equal positive 3. It doesn't matter about the numerator. You're not dividing by 0 with the numerator being 3 or 2 or negative 2. It doesn't matter. But the denominator, we have 2 exceptions. These are the only places where we would divide by 0. So if I'm asked to find the domain, which I am, my answer is this. It's all real numbers, except x cannot equal 2 values. It cannot equal plus or minus 3. And that, I'll just write it easy. You can list them separate if you wanted to. You can put a comma there. But because it's positive and negative 3, I'll write it like that. All real numbers, except x cannot equal positive or negative 3. If you were to plug in the number 3, look at what would happen. 3 squared minus 9. 3 squared is 9 minus 9. You would take this and divide by 0. Divide by 0 doesn't exist. It's undefined. It creates a vertical asymptote at that point. If you plugged in negative 3 squared minus 9 would create 0 as well. You can double check it that way. Okay, so here's what I want to do before I go to the next problem with the person you're sitting next to. What does this mean? When I says what's the domain is, what does that mean and why can't we use it? Let's have the person sitting on this side of the room, we'll call them the south person, explain to the north person, what does this mean and why can't, what does it mean? Discuss. Okie dokie. Example number 2. Example number 2 is number 14 in your homework. And it says this: select the correct multiple choice response in each question below. Why is there a question mark right there? That's my question. Should that not be there? That should be just like a period, right? See? And I didn't even write that one. There you go. Number 14. When is this true? When is 3x minus 21 divided by x squared minus 49 equal to 3 over x plus 7? Is it true for all values of x? Is the domain all real numbers? Is it for all values except negative 7? For all values of x except 7 and negative 7? Or never? And so this is a direct application of what you just learned for domain. If I were to divide by 0 here, would that be true? Let me just look at this side, because this side's already done for me. Does the right-hand side have a limited domain? Is there something that x cannot equal on this side? So right off the bat, I didn't do any work. I already know all values except x equals negative 7. We can't have it being negative 7 for sure for the right-hand side. But I see this has a negative 7 in it, and there's a positive 7. I wonder, let me go over here. Switching colors to blue. I thought I was. Is there something else that on the left-hand side that would cause me to divide by 0? Are there a couple things that x cannot equal on this side? Do you see it? What 2 values on the blue side? If you know, tell the person you're sitting next to what x cannot equal. And so our correct answer here would be which letter? If you know, say the letter to your partner. I heard a lot of C's. Now I just want to do this just for my own knowledge, or for anybody who doesn't understand. The blue side, if I were to factor the top, 3x minus 7, if I were to factor the bottom, x plus 7, x minus 7. That's the blue side. Dang. The red side is this one. Technically, if somebody were to go over here and say, we could reduce this, couldn't it? So shouldn't it only be negative 7? Well, don't forget, before we reduce, before anything gets reduced, you have to make your determination before you reduce anything. So if there is a limited domain, the limited domain happens before any reductions occur. Whatever I'm trying to say. Making sense? Last example. Simplify. Assume no denominator can equal 0. Number 19. This says 3x and negative 3x, and one's a plus sign, one's a minus sign. Can they reduce right now? If I wanted to, could I reduce those two things? I'm hoping you know the answer based off of what I told you before. The answer is no. You cannot reduce these because this is being added to that group. It's not a group of multiplication. The only way to turn these addition signs and subtraction signs into groups of multiplication is to factor. And so that's what we're going to need to do. It says to simplify. So what I'm going to recommend that you do is that you look for a way to factor, let's say, this top left piece that I've circled in red. Is there a GCF? What is the GCF? If you factored out a GCF of an x, what's left inside the parentheses? And so that's what the top left is. What about the bottom left, the denominator? What would the bottom, I'll put this one in a box, this red rectangle, what does that factor to? Yeah, I'm thinking of difference of squares. If you take the square root and you take the square root, you add one set of the roots and you subtract one set of the roots. That is how you factor the difference of squares. It should be a plus x times a minus x, or vice versa. Next, multiplied by. Now I'm going to do this upper right hand side. Is there a GCF of this blue circle? What is the GCF of that blue circle? What's left in parentheses? Now I'm going to do the denominator, and I'm going to look for, I think this only has GCF factoring in it. What's the GCF of 9a minus 3x? And what's left behind? Now that you have groups of multiplication, this is multiplying this group, 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 and that's multiplying that group. You can reduce. You can't reduce when you have adding and subtracting, but groups of multiplication, when there's a bunch of parentheses, there's no plus signs, minus signs outside of the parentheses, we can reduce. Here's what I'm going to show you. 3 divided by 3 goes in one time. I could put the 1 there, but there's no need to. 1 times anything is itself. Let me see what else I see. I see an a plus x goes into a plus x 1 time. I see one other thing that you may not see. This and this are almost the same thing. This 3a is positive, but that 3a is negative. This x is negative, and that x is positive. If you ever see something in parentheses that's exactly, almost the same exact thing except different signs, everything's a different sign or a different order, check and see if you can factor out a negative. I'm going to put a little star. Factor out a negative. Sometimes, if you factored out a negative 1, let me just do this right here in blue. I'm going to factor out a negative 1 right here. If I have a negative 1 factored out from a positive 3a, that's going to make that a negative 3a. Because this times that would equal that. And I'm going to put this in parentheses. This times that is that. If I factor out a negative 1 from the minus x, guess what that makes that? Makes it a positive x. When you do that, x minus 3a, this is what I have now. X minus 3a. If you ever see these things being the exact same thing, you want to factor out a negative if they're just opposites of each other. That way, you can do this. Now it's almost done. I have an x on top. I have an a minus x on bottom. I have a negative 1 on bottom. I'm going to put the negative right here. Because times negative 1 would either have to change this sign and this sign, or we can just put it in front. Matter of fact, I think some people would do that. Let me put the negative 1 right here. Erase that. And some people would do it like this. Negative a, positive x. And you can't reduce that, so you would leave it like that. That'll keep 1 extra negative out of the answer. We're going to stop your notes right there.